We'll start with this problem, 15.1a, and we want to come up with the characteristic equation, which is easy enough to write. That would be r squared minus 7r plus 10. And then we want to solve for r. This is easy enough to do by hand. We'll factor this like we did back in beginning algebra. So we got r equals 5 and r equals 2. So our solution would look like this. So we will, just for the heck of it, check this one. To do that, we need to take the derivative of what we just came up with. So bring down the a. Derivative of e to the 5x would be 5 e to the 5x. So that would be a 5a e to the 5x. And this would be 2b e to the 2x. Sorry. The derivative of that then would be 5 times 5 is 25 a e to the 5x. And 2 times 2 is 4 b e2x. Plugging those back into the original, we have y double prime minus 7 y prime plus 10y and hopefully that comes out to be 0. So this is negative 35 a. This is negative 14b. This is 10a. This is 10b. So we got 25a e to the 5x minus 35a to the 5x. That's negative 10. Plus 10 is 0 e to the 5x. We have a 4b e2x minus 14b. That's negative 10. Plus 10 is 0. So it checks. Now I'm going to do just this one initial value problem to show you how to handle finding the two constants in the initial value problems. So characteristic equation. So we write our solution. Now to find the constants, we've got right here y of 0 equals 0. So we will plug in 0 for x, 0 for y. So that would be 0 equals. Now that would be a e to the 0, which would be a times 1, plus b e to the 0, which would be b times 1. Then we will do the derivative of y. So we can use the other condition. So the derivative of this would be plugging in the 0 for x and 1 for y prime. We get 1 equals negative 3a times e to the 0, which is 1, plus 3b e to the 0, which is 1. Now, from back in college algebra, we have a system of two equations and two variables to solve. Now that's easy enough to solve by hand. I'm going to show you about using your calculator. Some of you may have done this. You may remember doing this. This is called the Gauss-Jordan method. And to use this method, we're going to form what's called an augmented matrix. We take the coefficients 1, 1, and 0. So we're going to make a matrix that goes 1, 1, 0. That's this equation. This equation is negative 3, 3, and 1. We're going to type that into our calculator and do the reduced row echelon form, also known as, and so let me take out my calculator and we will do that. Now in your calculator, you're going to go to the Alps and Data Matrix Editor and create you a new matrix. We'll give it any name you want. I'm just going to use an M for mine. And the rows would be 2, and the columns would be 3. Enter, and we enter the number. Back to the home screen. Now we're going to do the RREF. You can get that in the catalog by going to the R's, or you can type RREF and then the name of the matrix where you typed it, which mine was M, and this is what we get. Now remember, if the left hand side is 1, 0, 0, 1, then these are the two solutions in the order A, B. So in solving that, we come out with the solutions A equals negative 1/6 and B is a 1/6. And so our final answer would say y equals negative 1/6 e negative 3x and plus 1/6 e positive 3x. Alright, let's take a look at this. Characteristic equation, r squared minus 8r plus 16 equals 0. We can solve that by factoring. So two things that multiply to give 16 and add to give an 8 would be 4 and 4. Negative on both. So we get r equals 4 and r equals 4. So in this situation, we have duplicate roots to the characteristic equation, meaning our solution would look like this. Y equals, we would have our constant times e to the 4x, and our other constant times x, e to the 4x. Now, I won't go through the process of checking these, but that's the idea of that. Video's getting kind of long, so I'm also not going to find the exact equation using the initial conditions. So I'll leave it up to you to find the A and the B, and I showed you how to do that on the previous problem. Okay, on number 5, let's take a look at the C problem. Characteristic equation, r squared minus 2r plus 5. Now, I'm going to take my calculator and solve this. You can probably tell from the section that it's in what's going to happen if you watch the instructional videos. However, if I go to my F2, solve, I'm going to type r squared minus 2r plus 5 equals 0. So if we try solving for r on our TI-89, we get just this. It says false. Now that's our clue that the solutions are complex. So the solve doesn't work with complex solutions. Instead, we have to use C-solve. So we're just going to put a C on the front of the solve. Now in the algebra menu, there is on down the line a little bit somewhere a C-solve. So anyway, C-solve gives us the two solutions, 1 plus 2i, 1 minus 2i, which we can write conveniently as 1 plus or minus 2i. Now again, it's talking about giving the answer in real terms. Now, if you recall, these two numbers, the significance of those two are, our answer would be y equals constant e to this number x, that would be 1x, cosine 2x. And then b, e to the 1x sine 2x. There's our answer. And finally, let's take a look at 15(6e), where the characteristic equation would be r squared minus 4r plus 13 equals 0. Now you can solve this with the quadratic formula, or like we did on the last problem, we can take out our handy dandy calculator, and it says 2 plus or minus 3i, which tells us that our solution would be constant e 2x cosine 3x, constant e 2x sine 3x. Now I'll go ahead and do the initial conditions on this. These are a little trickier. So first off, the y of 0 equals 0 means we plug a 0 for y and 0 for x. Well, now 0 for x would give me a times e to the 0, that would be 1, cosine of 0, which is also a 1, so that would just be an a. Over here we'd have b, e to the 2x is 0, and sine of 0 is also 0. So we don't have anything in this second spot, so we already have a equals 0. We still, however, have to do the derivative and use the other condition. So let's do the derivative of this. Product rule. This is not going to be nice looking, but we've got the derivative of a e to the 2x, which would be a 2a e 2x, cosine of x, cosine 3x, sorry, plus, bring down the a e 2x, do the derivative of cosine 3x, that would be negative sine, negative a e 2x sine 3x, and then product rule here, the derivative of b e to the 2x would be 2b e to the 2x plus, bring down the b e to the 2x, the derivative of sine 3x would be 3 cosine 3x. Now, we've already determined that a is a 0, so we can plug a 0 in for a, 1 in for x, a 0 for x, and a 1 for y prime. So we got 1 equals, now this 2a would be 2 times 0. So it doesn't matter what the rest of this is, that's going to be gone. Plus, and again, the a is a 0, so that's going to be gone. And we've got 2b e to the 2x sine 3x. We're going to plug a 0 in for this x. That'd be 2b e to the 0, which is 1. Sine 3x, sine 0 is 0, so that's gone too. And here we've got 3b e to the 2x. 3b e to the 0 is 3b. Cosine 0 is 1, so that comes out to be 3b 3b. So all of this comes out to be just 3b, which gives us b is 1/3. So taking our solution here, and we would say y equals, and that's our answer.